Alright, so we looked at the different types of nuclear radiation and nuclear decay, and now we're going to look at how we use them in nuclear equations. So when we talk about nuclear equations, there's one law that really is the overseer of everything we do when we are looking at the nucleus changing. That's the law of conservation of matter. And remember, it states that matter or mass cannot be created nor destroyed. That means you can't make matter out of thin air, and once you have matter, you can't just make it magically disappear. Whenever we're using nuclear equations, we use isotopic notation. So, quick review of isotopic notation. We're going to write the isotopic notation for oxygen 16. So, we use the information provided here. Oxygen is our element, so we're going to write the symbol for oxygen. Hopefully you know this one. It is a capital O. So, O for oxygen. So, we've got our symbol. Now we're going to move on to our numbers. Oxygen 16, remember anything listed after your element, this is your mass number. And in isotopic notation, that goes in your top left corner. So we're going to put 16 up in our top left corner. And in our bottom left-hand corner goes the atomic number. This is what you get from the periodic table. So look at the periodic table, find oxygen, its atomic number is 8. So we're going to write 8 in the bottom left-hand corner. And remember, in isotopic notation, there's one more thing. It goes in the top right, and that's your charge. When we're dealing with nuclear things, that's pretty much all in a neutral state. So we're pretty much never going to have a charge in there. So we can just leave it blank. All right. So let's look at our first practice problem. Now you need to be able to know which type of decay is which, so you can label each equation that you look at. Here we have bismuth 214. It's undergoing nuclear decay and it lets off a helium atom. We know from our nuclear decay that a helium atom means this is an alpha decay. So we're going to label it as an alpha decay right there. And we're going to try to figure out what bismuth turns into. Okay, it's releasing its alpha particle and it's becoming something new entirely. So we're going to figure out what should go where this question mark is. So as we look here, we're going to use our law of conservation of mass, and we're going to use some very simple math to figure out what goes into that question mark. So let's look here. We're going to separate our atomic numbers and our mass numbers. So we're going to look at the bottom numbers, and then we're going to look at the top numbers. So as we look at the bottom numbers, remember that these equations are separated by the arrow. It's sort of like your equal sign in math. It shows you which side is the left side of the equation and which side is the right of the equation. So the left side has to equal the right side. What I mean by that is the left side, we have an atomic number of 83 right here. Okay, so that is what we're going to have to equal on the right side. If we have 83 on the left, we have to have 83 on the right. So far, we have a 2. Okay, so we have to figure out what we have to add to 2 to get to 83. Okay, so whatever you have to add to 2 to get to 83. Now, that may seem like a hard math, but you should know it. It's 81. Okay, so our new atomic number is 81. Okay, now you do the same thing for your mass. Okay, we have 214 at the top on the left side. On the right side, we have a 4. So we have to figure out what we're going to add to 4 to reach 214. Hopefully you can figure that out. It is 210. Okay, now we need our symbol. Our symbol for our element, we look at the periodic table, we find atomic number 81, and we see that it is symbol TL. Its name is thallium. Okay, so bismuth 214 is undergoing an alpha decay, so it releases its alpha particle, and it turns into thallium 210. So we were able to figure all that out just by looking at the equation. Let's try another one. Here we have neptunium 239, atomic number 93, and it is turning into plutonium, which has a mass number 239 and an atomic number 94. So we're trying to figure out what type of decay it is and what that mystery particle is. So as we look here, remember our law of conservation of mass is how we're doing. So if you look at the top, we have a mass of 239 at the top on the left side. And if you look at the right side, we already have 239. So if you have to add something to 239 to get the answer 239, it's just a big fat 0. Okay, 0 plus 239 gives you 239. So we know our mass for this particle is 0. Looking at the atomic number, we have 93 on the left, and we have a 94 on the right. Okay, so we have to have 94 plus something to give us 93. Now this is where it gets a little tricky in your head, so make sure you get it straight in your head, okay? 94 plus x equals 93. It's like an algebra problem. So we're going to do 94 plus -1. Okay, 94 plus -1 will give us 93. If you do 94 plus 1, if all you do is write a 1, 94 plus 1 is not 93, it's 95. Okay, so make sure you're not making that mistake. 94 plus -1 will give us 93. And see here we have a mass number of 0, an atomic number of -1. We look at our type of radioactive decay, and we see that an E should be there. And we know what type of particle this is. It is a beta particle. So we can label this equation as a beta decay, and it lets off a beta particle. So you can also look at it in a word problem. So here we have a word problem. It says, write the nuclear reaction for the decay of Am, which is americium 241. An alpha particle is released. What is the new element formed and what type of decay is this? So it's asking us two separate questions. So we need to make sure that we answer every question it asks. Okay, we cannot just answer the first question and think we're done. It asks us two questions, so we need two answers. So we're going to write out that equation. We're going to write the nuclear equation for the decay of americium 241. So let's start with what we know. Americium 241, we're going to write Am. We're going to write 241, and it has an atomic number. We look at the periodic table, it has an atomic number of 95. Okay, it's undergoing decay, so we're going to draw our yield arrow, and we're going to draw what type of decay it was, and we know that from the question. So you go back and you see an alpha particle is released. So if an alpha particle is released, we're going to write in our alpha particle. We look at your types of decay, we find alpha particle, and we see that it is a helium nucleus with an atomic number 2 and a mass of 4. Okay, so we have americium and it's decaying into our alpha particle plus a brand new element which it is making, and we figure that out with our math. So you look at the atomic number, we have 95 on the left side and we currently have a 2 on the right, so we have to add something to 2 to reach a total answer of 95. So we know that it is 93. Okay, as you look at the mass of it, we have 241 on the left side, and we currently have a 4 on the right. So we do 241 minus 4, and we get 237. So when we write in our symbol, we have an atomic number 93. You look at your periodic table, find number 93, and you can see that it is element Np or Neptunium. Okay, so this word problem is a little bit more difficult to read, but essentially it's the same type of problem. You're just going to write out your equations. All right, last example that we're going to do, write the nuclear reaction for iodine 131 gaining an alpha particle. So this is slightly different. We've been writing the decay for everyone, and now we have iodine 131 gaining an alpha particle. That means it's taking an alpha particle into its nucleus. So mathematically, how do we show something combining with something else? Well, that's addition. So we're going to have our iodine 131. We're going to put our I. It's mass 131. Okay, look at the periodic table. You find I for iodine, and it is atomic number 53. It's going to gain an alpha particle, so we're going to do plus an alpha particle. So we're going to write in an alpha particle, He, atomic number 2, mass 4. And then we have our arrow of what it turns into. So this is actually the easiest math there is because it looks like an actual math problem. We have 131 plus 4, so our right side of our equation will be 135 for its mass. We have 53 as the atomic number on the left plus 2, so 53 plus 2 means we're going to have an atomic number of 55 on the right side. Look at your periodic table, find 55, and it is Cs or cesium. So here we go. It's the same type of question, it's just in a slightly different way. Instead of decaying, we are gaining the alpha particle. Now you should have some more practice that you can do. There should be a key for you, so make sure you go and do that practice.